Lesson 8-7 is about vectors. This is an interesting subject in that you will use this a lot more next year. Kind of a cool thing. They're not just arrows. They're just sort of different than anything else we've talked about. So here's some vocabulary that I want you to write down while I'm explaining them. A vector is anything that has magnitude and direction. So what the heck is magnitude? It is the length of the vector. So if you are on the coordinate plane to find the length, you're going to use distance formula. The direction is the angle formed by a horizontal line. So that's what this over here is, this line. It's to show you the angle. So direction is always expressed in degrees, and we will probably need to use sine, cosine, and tangent to find that, especially on the coordinate plane. The standard position, it's the, I forgot to finish that one, the initial point at the origin. That means if your vector is placed so that the initial point is at 0, 0, then your vector is what's called in standard position. And then there's a special way to write a vector, which is in component form. And basically you're looking at the rise and the run of your vector. What is that? And you notice those are not parentheses, those are pointed. So that's what you need to use when writing a vector. All vectors have those sort of greater than or less than looking parentheses. Okay? So in example 1, it says write the component form of AB. So here's vector AB. In point A, the initial point is at 1, -4. So on your graph, -1, -4, that's where your initial point is. That's A. Your terminal point, or point B, is at -5, -1. Okay? So go ahead and graph your vector on your graph. And to find the component form, we already have our formula right up here. It's basically finding the slope of the line, only it's not a fraction. So vector AB, the component form, there's our funny looking parentheses, is -5 minus -1, and then comma for the second point, -1 minus -4. We want to simplify that, so we can also write AB in component form as -4, 3. So there's our component form. Okay. Example 2, we're going to find the magnitude and direction of ST. I'll go ahead and let you plot ST on your graph. And remember, magnitude is length, so we're going to be finding the distance formula. And this is how we write magnitude of ST. We use these double lines. It does not mean absolute value. Alright, so let's use our distance formula if you remember it. And let's plug it in. 4 plus 3 squared plus 7 plus 2 squared. Alright, let's go ahead and simplify that. 7 squared plus 9 squared. Okay, go ahead and square those and add them together. And we get the square root of 130. We want to go ahead and actually evaluate that, and we're going to round to the nearest tenth. So this is about 11.4 units. That's how long our vector is. Okay? Now remember, the direction, it has to do with the angle formed with the horizontal line. So in our picture, I'm going to use some highlighters. Horizontal line. Here's my horizontal line. And I'm going to draw that so it looks like a triangle, because my direction is this angle down here. That's what I want to find. Now, I know all three sides of this triangle, because this side over here opposite the angle is vertical, so I can just count those. So that's 9 units tall. And this line side adjacent to the angle is 7 units. So is there a trigonometric function I can use to find the measure of that angle? Think about SOHCAHTOA. I have the opposite and the adjacent. So yes, I can use the tangent. And that is point S. So the tangent of S is 9/7. How do you figure out what S is? Yep, inverse tangent of 9/7. Let's round it to the nearest degree. And you get 52 degrees. That is the direction of the vector. Alright? Okay, example 3. Copy the vectors to find A minus B. Here are my vectors. They don't have to necessarily be the exact same length, but they do need to be pointing the same way. Vector A is vertical and vector B is horizontal. Pay attention to where the arrow is. It's up, and then the other one is pointing to the right. To do vector addition and subtraction, what we do is first we look at our first vector. It's A. So I'm going to just copy A. I'm going to sort of sketch it out about the same length, and I'm going to label it. Okay. Now, since it says minus B, that's sort of like the opposite. So B is pointing to the right. So I'm going to draw B pointing to the left to symbolize subtraction. And I want to take note about how long it is. And so from the top of A, I'm going to draw B pointing in the opposite direction. And that's minus B. To figure out the resultant, or the vector that's formed from that subtraction, I'm going to start at my initial position with vector A, and I'm going to draw a vector up here to connect where vector B ended. So right here, that is my vector, and I'm going to label it A minus B. So the orange vector is my answer. It really helps to use highlighters. Okay, example 4. You got to know your directions. If you don't, never eat soggy worms, Wheaties, whatever you have nicknamed it. It says, suppose a person is canoeing due east. I know it says doe, I messed up. Due east across a river at 4 miles per hour. So east is to the right. So I'm going to draw a vector east, and it's going 4 miles per hour. Remember, that is the magnitude, that's the length, the speed. Then the river is flowing south. So south is down, and it's flowing south at 3 miles per hour. I want to find out the direction and speed of the canoe. So if I'm canoeing east, I'm probably not going to go east because of the river. The river's pushing me down. This is my path that the canoe is going to go. What is the speed of my canoe? Well, remember, speed is the same as magnitude. Okay, so I want to find the length of that vector. Well, that triangle looks an awful lot like a Pythagorean triple, and it is. This is a 3, 4, 5 triangle. So my speed is 5 miles per hour. How about direction? Well, the direction, I need to find the angle formed with the horizontal. So this angle right here is what I want to find. I can use any one of my trigonometric functions, but usually I use tangents. So my resultant direction, instead of just going east, is the tangent inverse, remember, because we don't know the angle, opposite over adjacent, which is about 37 degrees. Okay, so the wind, or not the wind, the river is pushing me 37 degrees down from where I want to go. Alright, so look over your concept summary. This is the last section in Chapter 8, so be prepared for Chapter 8 review next time.